Near the does the screen has appeared to you? Near screen has appeared to you? Steam generator. Today, the topic is types of boiler. It's how it works. What is the difference between one boiler to another boiler? From your VTU syllabus point of view, it is mainly industry point of view. In the market today, you will not find these types of classification. This classification will be like if you consider the car, ambassador car to today's different types of cars are there. Those classification, such things will be put in a systematic way in the UVTU syllabus. But in the market, you don't find ambassador car, Fiat car, or 1940 type of car. These world classification are the type they have kept it in our syllabus, but in the market you don't find any one single type of banner. They go on improve the performance and functionality and appearance and hybrid type of boiler we will be finding. So that type of a present market boiler in detail, construction, function, all the boiler mountings, boiler accessories, how it is uh, fabricated. All these things really very well is explained, explaining by industry expert Ramesh. It is fortunate to get that type of person. Anyhow, practical exposure you get about the total boiler. So that is the reason we have mentioned uh, industry person on this topic boiler. Now coming to this steam generator, a steam generation or the steam generators are nothing but a boiler. Boiler is a general word. Steam generator is the engineering technical word, mechanical technical word. Boiler or the steam generator. So steam generator, also called boilers, perform one of the major process in a thermal energy cycle, vaporizing water to steam. Steam may generate mechanical power or supply heat to a manufacturing process. The complex equipment in a steam generator evolved from the simple uh, cauldron of Hero's engine of ancient history. This is steam generator. If you consider this as the boiler steam generator, we supply feed water and uh, heat transfer will be there. Then heat generation, boiler drums will be there, and auxiliaries and accessories will be there. Uh, Ash removal, instrumentation, draft system, fuel preparation, and in the furnace, fuel burning equipment will be there here. There is a heat supply like this heating and water walls, slag screens, floor tubes, economizer, air heater will be present here. For this, heat will be transferred and the steam will be sent. All units have furnace and fuel burning equipment. Some or all of the components of heat transfer are used in units of various design. This is the general block diagram of the steam generator. In the examination, you will be asked to write the boiler figure. For that boiler figure, a simplified boiler circuit diagram they have given. There's a circuit diagram in practice, that is enough. That circuit diagrams I am going to show you now. How water is circulated inside the boiler is by two means. One is natural circulation, another one is forced circulation. These advanced uh, designs of the boiler, they are the different feature that makes these units different are forced circulation will be there. The tubes will be very small in diameters that you have seen in the industry person's video and the photos, images. A lot of tubes, how small it is, how lengthy it is, all these things, the tubes he has shown. Lack of drums, pressurized combustion, multiple tube circuits, extreme compactness and low weight. So these are the features that makes the advanced design in the boilers. So these advanced features are incorporated in the different types of the boilers. Those boilers are there in your syllabus. Now, what are the various boilers are? Look at this. Lamont boiler, Loeffler boiler, Benson boiler, Smith-Hartmann boiler, Velox boiler, Ramsden boiler. Look at this. Velox boiler and a Ramsden boiler. These are the different boilers, six boilers they have mentioned in your syllabus. Okay. Now let us look one by one what is the difference or how it functions, etc. Now you can see Balaji VR. Balaji VR, can you speak? There is no quick response from you. Kiran R. Kiran R. Can you speak? Anil Kumar Vassar. Vivian Varun. Vivian Varun. Can you speak, Vivian Varun? Prajwal S. Bhatt. Prajwal S. Bhatt. Nobody is speaking. You joined or shall it? You have simply connected and you have quit your place. Have quit your place. Prajwal S. Bhatt, speak or reply in the chat box. Subramanya Shivaram Gavankara. Rajat Kumar S. Rajat Kumar, can you speak? No reply from anybody. What happened? Okay. Assuming that your screen has appeared. So look at this. Lamont boiler, Loeffler boiler, Benson boiler, Smith-Norton boiler, Velox boiler, Ramsey boiler. These are the 6 boilers are there. The circuit diagram they have shown. So now, see, FP means feed pump, WC is water circulating pump. Representation you look. D means drum, E is economizer, SC is steam circulating pump, CS is convection superheater, RS is radiant superheater, T is tube operating sections, O is steam to service, WS steam separating section, TS transition section, AC air compressor, GT is gas turbine. The convention used to represent the flow of the steam is this is water is like this, flue gas a dotted line, air is like this. This is the way. this is the way they are represented. Now look at this. Let us take one by one. So in the Lamont boiler, the Lamont boiler starting point. Starting point here. The water is taken into the feed pump. From there, it flows to the evaporator, economizer section. From there, it is sent to the boiler drum. From the boiler drum, the water comes to the water circulating system. From there, through these tubes, uh, it flows through the tubes in the water tubes, and from this the steam generated is sent to the steam drum. From the steam drum, the steam is sent to the convective superheater. From the convective superheater, the steam is sent to the application. Turbine. And look at this. Now further, the flue gases are passing over here. This is how the flue gases are flowing. This entire thing, water tubes, tube evaporating sections. These two evaporating sections can be kept. This entire thing is kept separate. So that is the advantage of this one, Lamont boiler. Now I will repeat it once again. Okay. Now let me repeat this one. Start from here. This is the starting point. Pump. We have to convert water into steam by passing through the tubes. On the tubes, flue gases are flowing. That is why we start from here. So the feed pump, water is sent to the feed pump. That feed pump sends to the economizer tubes. From economizer tubes, it is converted into steam with moisture. That is sent to the steam drum, and then from the steam drum, the steam or the with moisture with water comes to the uh, transition tubes. So through these tubes, the water and the steam will be flowing. It is converted into steam. That steam is sent to the boiler, and from the boiler, it is sent to the convective superheater. From the convective superheater, it is sent to the turbine, steam turbine. Application. Now look at the how the these flue gases are flowing like this. In all these regions, the flue gases are flowing. So that's all. This diagram you have to practice it. Is it okay? Understand? Let me ask you. Is it understand? Ishantar, Abdul Kalik Pasha, Nihar.
Yes, sir.
Is it clear?
Yes, sir.
Okay, thank you. Vidyan Prakash. Okay. Sanjay Raghav. You do not simply putting your USA number in the chat box. Is it understand? Rajat Kumar. Nirav Nembag. Nembag. Okay, fine. Rajat Kumar, I have seen. Nirav, reply. Nirav, why did you join late? Nirav, Nembag. Nirav, reply. My network is slow, sir. It's all right. If you understand, it's enough. Okay, right. Now let us go to the next one. Water enters outlet. Outlet. Water is enters here, and steam comes out.
Sir.
Yes. Yes. Please tell me. steam outlet. This is water. Water is entering there, and after converting into steam, it is going out. Now coming to this boiler, this low floor boiler. Again, you start from here. So water enters here through the feed pump, and the water is coming like this, and it is flowing to the economizer. From the economizer, it is converted into hot water. That hot water, it enters into the steam collector, this drum, and from this drum, this becomes partly steam. That steam is collected in the steam collector, that is sent to the radiant superheater. From the radiant superheater, it goes to the convective superheater. From the convective superheater, some water and steam comes like this. Remaining steam goes outlet in the upward direction. Outlet to the steam turbine. Here, this part, I'll show you in just a minute. This is extra. Extra part, radiant. RS is not there in the Lamont boiler, and there is no these tube evaporating section is not there. Now further, let us see what is happening. From the convective superheater, this comes like this, and it is mixed with water coming from the feed pump through economizer. Then that is sent to steam collecting pipe. This is how it is. Now coming to this Benson boiler, once through boiler. This Benson boiler is called once through boiler. Once through boiler. This Benson burner is called the once through boiler. Why it is called once through boiler? As the name says, once through, once for all, everything is heated and supplied. You start from here, feed pump. Always start from the feed pump. From the sump or the river or the reservoir, water is sucked by this pump, and that water is pressurized, and that is sent to this economizer. From the economizer, that hot water is sent to this tubes like this. Okay. Then afterwards, this becomes steam that is sent to the transition section superheater. Then it is sent to the convective superheater. From the convective superheater, it is sent to the outlet. So there is only one direction of flow is there. That is where it is called the one-screw boiler. Benson boiler is mostly used in most of the industries. However, hybrid boilers are there. Just to say, Benson boiler is used. Mostly it is used. So similarly, Smith-Hartmann boiler. So in the Smith-Hartmann boiler, it is taken from the feed pump to the economizer that goes to the steam drum, and from the steam drum, the steam is sent to the convective superheater to outlet, and here secondary circuit also they have added. That is this one. The steam flue gases are flowing like this. This is the steam drum. It is taken and it is sent here, and that is how water is also heated like this in the secondary. Okay. Now coming to this Velox boiler. The Velox boiler, the feed pump, water is taken, economizer, then it is sent to the water collecting, then it is passed through this, and that is so that is sent to the air compressor, and from there it goes out. The turbine rotates. Then the steam is taken from these tubes, sent to the convective superheater, then to the outlet. Now, where this one, the flue gases is flowing, steam separating section. This is the flue gases are flowing like this. It is how the flue gases are flowing. Coming to this Ramsyn. In the Ramsyn, so start from here, feed pump. So hope you remember starting point, feed pump. From feed pump, it is sent to the economizer. From the economizer, it is sent to the transition tube operating section, and then to the convective superheater to the outlet. This is how it goes. And flue gases. So flue gases are here. They are flowing here. The flue gases are flowing like this. Now let us see some of the points. So Lamont boiler, flexibility in placing the heat transfer surface for best advantage. Forced circulation units uses small diameter tubes. This is the advantage. Because of the small tubes, advantage. Give unit and high specific output. This is advantage. High specific output is the advantage of the Lamont boiler. It is used mostly in United States as a controlled circulation boiler. Coming to this low floor boiler. So low floor boiler. Feed water passes through economizer. Feed water passes through economizer on its way to a drum external to the solvent. Superheated steam mixing with the drum water evaporates it to saturated steam. So here, say 2/3 of superheated steam returns to the drum. 1/3 it moves upward, leaves in the upward as a steam generator output. Pressure is 2000 pound per square inch gauge. Pound per square inch gauge, PSI. So this is salt. This units can handle drum salt concentration as high as 8,000 parts per million without trouble. This is the advantage. These are the advantages. Coming to this Benson boiler. So Benson boiler are called the one screw boiler. It do not have drumless. Advantage. One screw boiler. It is advantage. Takes boiler feed water in at one end and discharges it as superheated steam at the other end. That is the advantage. The steam flows through higher temperature superheater. That is the another advantage. The lightweight is another advantage. 15 minutes starting boiler can be started in 15 minutes. That is another advantage. And pressure is this much, 400 to 3,500 pounds per square inch gauge. These are the advantages over other boilers with respect to Benson boiler. So Smith-Hartmann boiler, this multiple circuit boiler, this is a multiple circuit boiler, mitigates water, feed water troubles, because separately they are circulating feed water, that is why. And the rest of the things is as usual. Coming to this Velox boiler. Coming to Velox boiler. The pressurized combustion chamber furnace of this boiler uses low excess air and has high transfer rates. That is its advantage. And see, pressure is low pressure here. The gas turbine, it is having a gas turbine, drives the axial flow compressor that raises incoming combustion air from the atmosphere to the furnace. This compact unit develops a high efficiency. This is the advantage of the Velox boiler. And pressure is this range, temperature is this one. I'm going to this Ramsin boiler. This Russian One screw boiler has inclined coils T arranged in spiral form. 40 coils are paralleled around the furnace. Steam generated in the headers flows into headers and then to the superheater. So today's topic, the industry person has spoke about these headers. The boiler work at various pressures and are built of standardized parts. The supercritical pressure boilers now being built in the United States use the one screw principle. These will be discussed. Okay, that's enough. So, a Ramstein boiler is one of the supercritical boiler example. And that supercritical boiler or that industry person in depth he is explaining. This is about your VTU portion, VTU syllabus. So these boiler figures you have to practice it. I hope it is clear. If you have any doubt, you can ask. Do you have anything to ask? Nilesh, any doubt? Gunasagara, Ankesh Aman. So all of hope you have put your USA number in the chat box. The class ends now. If you have any doubt, you can feel free to ask. The class ends now.